Hi, my name is Gavin. I work for a company called Vision One. We're an MSP in the Cincinnati-Dayton area. I've created this workflow as a way of monitoring the Meraki networks that we are in charge of. And it'll send us text, a Teams notification if the latency or packet loss percentage reaches past a certain threshold that we're going to set in this workflow. It'll alert us and then log the alert. That way, every minute, 5 minutes, 30 seconds, however many intervals you wish to have this workflow run, you're not getting alerted every single time it runs. We will be storing it in a Redis database with a TTL, giving us the ability to delete the key and re-notify us if the problem still exists after a specified time that we'll set again in this workflow. So let's get into it. So here we have the workflow in its entirety. I've split it up into 3 sections with the sticky notes. We have the pulling in info section. This is how we're going to get the information from Meraki. And then the middle section is just changing the data. This is how we're going to decide what to pass on from Meraki. And then we have the notification section. This is how we're going to log the alert, how we're going to notify our techs, and then we're going to log that message for X amount of time using the TTL function of the Redis database. That way we don't have a situation where a message kind of slips through the cracks. We will get re-notified if the site is still having issues after a certain amount of time, just making sure that we still know there's an issue to be looking at. Okay, so starting off with the first section, we have a HTTPS node here in the front. This is going to do a GET request to Meraki's API. As of right now, I have it set up to query specifically for this organization ID, that being of Vision One, the company I'm with, to pull in all organizations that your account has access to. You'll just take off the trailing ID field here I have, leaving the slash at the end, and that will pull in every organization that your account has access to. We're going to leave the authentication thing here set to none because we are going to specify the headers down below. So the 2 headers that the Meraki API will need is the authorization header and the accept header. This is where your API key is going to go. Your API key is just going to be a bunch of numbers like this, and then you'll have to add the prefix of bearer. And then for the accept, we just have application JSON. I have explained, or I have a link here for the Meraki documentation on how to get an API set up, or an API key set up. But really quick, I will just go over it. In Meraki, you will log into your account. 2 things I do have to specify. You do have to be a organization administrator. You cannot just be a network level administrator in Meraki. Because we are doing calls for organization data, if you are only a network admin, you will get a message in n8n roughly saying that whatever you're looking for doesn't exist or can't be found. That's just Meraki's way of saying that whatever you are looking for, you don't have permissions to see. And the second thing being SSO accounts cannot generate API keys. So this does have to be a standalone account that's not using Meraki SSO. So you will click your profile icon. You'll just click the My Profile. You'll scroll all the way down, and right above the Colorblind Assist mode, you should have a API key section, and you'll just click Generate New API Key. For this instance, I've generated this one to demonstrate with, which later I'll revoke and switch out with another one. But you generate the new API key, you'll copy all the numbers, and then, as I said, you'll paste it into the authorization header field with the prefix of bearer. Directly after the first HTTPS node, we have a set node. What this does is just it carries over the company name instead of just name. I made a company name. with the value of JSON name. That way it's an expression. That way for each organization we pull, it will carry this out. As well as the organization ID, keeping that, as we see here, coming from the ID field. This just makes it so that later on we have something to reference that's not named a bunch of different ways. We just kind of want to make sure things are neat, make sure that things are being referenced the same way across the whole workflow as best we can. The second HTTPS node we have does a GET request for all uplink loss and latency, the whole part of this workflow. So what this will do is it uses this API call here with the expression in the middle with the ID of the organization, because for each organization, we want to pull in all of the networks. Some organizations can have one network, some can have 5, 10. I don't know the exact max that Meraki allows, but you can have a lot of networks per organization, and each network can have their own ASA, and each ASA is going to have 1 to 2 uplinks. So you want to be able to pull in every network inside of the organization. This node does as such. Using the same authorization headers, same API key to pull this off. This will respond with the network ID. This is a little different than the organization ID. And it'll pull all of the info from Meraki in timestamps. And it pulls in 5. And it pulls in 1 every minute. So here we have, minute 48 through 52. And it looks like the average is sitting around 28 overall. And then as of right now, we're having a 0 packet loss on our WAN 1 uplink. On WAN 2, we're experiencing a little less latency with, again, 0% loss. Our third HTTPS node that we have is going to be the get network IDs. So all this is doing is just looking at the organization ID that we set up previously in the set node. And it's going to pull in specifically the network IDs that we want for the networks that we're going to be dealing with for the uplink loss and latency. And then it brings all that information over to here to our second set node, setting the network ID name, the network name, or network ID string, the network name, and then the network URL. Because in the Teams message, I like to have the functionality of being able to click a URL in our Teams notification that actually takes me right to the network having issues in Meraki, rather than having to log into Meraki, find the organization, find the network, find the ASA in question. We'll have a link that takes us right to it. That's something that Meraki is really good with, and that I find a lot of use. And I'm very happy Meraki gives us that. So now going over the second section, we use a merge node with the input from the network IDs. It has the URL, ID name, network name, and then our uplink statistics is in the input to section. So with our merge, we are merging by fields, and we are enriching the input of the first option. Filtering on the network ID and then network ID. The network ID in the top section is this actual ID. And then in the second section, the network ID is, again, the same network. If those match, then we are just going to combine the information. That way we have the URL and name from the set node up here, as well as the uplink statistics, all in one output. With our third set node in the workflow, we are just again setting the network ID, network name, network URL. Here we have the serial number, if we ever want to reference the serial number in question. We have timestamp 0 through 5's loss and latency latency. Defined. Just in n8n doing the drag and drop function, adding in your expression. That way, each input is handled the same. This brings us to our first JavaScript node. What this does is it calculates the average for latency and packet loss over the last 5 minutes using the code shown here. Not sure if the template will include this, but if not, this video does. So here's a visual look here that will calculate the average for latency and loss to then be looked at in the next node. So looking at the second JavaScript node, this I have titled filtering out problematic sites. What this does is it looks at the item for the average latency described in the previous JavaScript node, as well as the item for average loss. If the average latency as of right now peaks over 300 milliseconds, set this to whatever you prefer to be alerted. It will pass on the ticket data or statistics and company data, as well as for the average loss. I currently have it set at 2%. We've kind of noticed any packet loss over 1%, people can kind of feel it and notice it. So as of right now, for testing purposes, I've left it at 2%. If we come over and look at our uplink data now, it looks like we are averaging around the 20s to 30s for the latency on our uplink. So if you come over here and instead of 300, we make this, let's say 20. We'll go back to our workflow and run this node. It should pass it on because it's passing that 20 threshold, in which it does. Now we get into the third section, the final section. We have the notification section. The problematic site or problematic network will be sent to 2 different places. The reason I have 2 items because I have 2 networks using the same uplink. So changing that changes the error for both networks. First, it will send that info to Redis. This is how we're going to keep track of everything. It's looking for the network name. So as of right now, it's looking for Vision 1 network. As of right now, the node will respond null because we've not actually alerted for this ticket or this issue. So as of right now, this is a new issue. So the database is going to respond null because we've not seen this yet, which is good. Now in n8n, a null response, it sees as no data because while that's not wrong, it is hard to filter on it. So if I look at here, it'll say no data to show, items exist, but they're empty because they are null. They are no data. So using this JavaScript node, I've mapped it out so that if it responds null, it will respond that a alert does or does not exist. So we will execute this, and because we have 2 null responses, it will generate that alert exists is false because this is the first time we're seeing it. Okay, so looking at the merge node, we are now going to merge the information that we have a false ticket exists issue, as well as the problematic sites information. So coming into the merge node, all we are going to see from input 1 is that the network name is null because that's what Redis is responding with. And then if the alert exists, we are also now seeing false. So it's going to combine by network name and keep all non-matching. The reason we're keeping all non-matching is because if one of these were to respond with a site, then that means this string and the string from what is currently having a high latency, such as Vision 1 network, if they match, that means we have a ticket and there's no reason to push that forward. So we're looking at all non-matching. Any of these that say null are not going to match, and if we execute this node, it's going to push forward those 3 issues. Now looking at the teams node, or how you were going to prefer to notify your team. As of right now, I have a account called the V1 bot set to create a chat message to our dispatch group. You can set this up to teams, specific people, specific groups, however you prefer, and message type is text. So how I like to format my message is using the strongs for bolding, because that's how teams can handle it. It's going to use these as break lines. Overall, this is just the formatting of the message, how we're going to send this to our techs and teams. So as of right now, we're going to get this alert because we are passing I had to go back and change it, a 5 millisecond delay or latency, because we are now below 20. So what this is going to do is we have the loss and latency alert. This is going to be our main title. It is strong for bold. It's going to be a bolded message. And then we are going to break the line or hit enter twice. And then our next bolded message is going to be the network name. This is where that URL comes in. As you see on the left, we have carried this over the whole time. The network URL is, as such. And then using this dash or /a, and then making it Vision 1 network, this kind of makes it like a hyperlink. So in the message, all we're going to see is network name, Vision 1 network, but it's going to be, blue, clickable, and it's going to take us to this link here, which actually takes us to the network that's having a problem. And then we have the average loss, average latency. This is described with the strong, just to keep it bolded. And as we see, our averages are here. We're now breaking 5 milliseconds. So we're going to send this information on. Okay. Then I go over how we're going to log the alert. We're going to, we can run this now. We are going to log the alert with the network name in both fields, this string. I guess I have this disabled, it's not going to show it. But we merge on, or we store the key and the value as just the network name. So as right now, we're storing the key of Vision 1 network, as well as the value of Vision 1 network. So now, if we were to come back to this and rerun it, because we've now stored that data, the Redis node for the initial get will see that we now have these keys stored. Coming over to our JavaScript node, if we run it, it will now say that the alert exists is true because the alert exists. We just messaged our team about that alert. And then here we have the merge node, keeping on non-matching. As of right now, Vision 1 network will match the second input of Vision 1 network, and it's not going to push forward that data because we have an alert. Looking back at how we're going to log the alert, I have a TTL, these are set in seconds, of 10,800. This is 3 hours. So after 3 hours, if the problem still exists, what this does is it'll delete the key, And if the problem still exists, the next time the workflow runs, it'll see the latency, it'll pass the problematic average, send us a message, log the data, so on and so forth. That way we're not having a moment, like I explained before, that the issue is not getting looked at or has been forgotten. This will keep notifying you as often as you like based on your TTL. Okay, that does it for the tutorial part of this workflow. The reason I made this is that a lot of the times what we experience is that the clients will come to us and say, hey, we're experiencing some crappy internet. And rather than us logging into Meraki at that point, saying that, hey, yeah, your uplink has a lot of latency, your uplink has a lot of loss, this gives us the opportunity to get ahead of the game in a way. So rather than being reactive on the client side, where they're coming to you, you now have the opportunity to be reactive on the alert side. That way you can kind of get some information quicker. Right off the bat, as soon as the latency spikes, you're going to know about it. As soon as the loss spikes, you're going to know about it. That way, you can be like the superhero and kind of come to your client and say, hey, we know you're experiencing bad internet right now, and we are looking into it. Or, calling the ISP as soon as you see that issue and trying to see if there's like a known outage in the area, if the technicians are looking into it, trying to get some answers before your client feels obligated to come to you like, hey, this sucks. It makes you look more professional. It is a lot nicer, and it makes your job easier. And overall, I find it really helpful.